Today's video is going to be about operations with functions, and this is going to seem a little bit out of the blue with our polynomial functions, but knowing how polynomial functions work are going to help you simplify operations with functions, so it'll make a little more sense as we go along. First of all, what this means is that we can add, subtract, multiply, and divide functions. So those are operations: addition, subtraction, multiplication, and division. So we have two functions, f of x equals 3x minus 7 and g of x equals 13 minus 2x. If we wanted to find f of x plus g of x, we would just take these. F of x is 3x minus 7 and g of x is 13 minus 2x, and we want to add them together. So whenever we're adding these, we can just take them out of parentheses, and that's going to give us x plus 6. We just combine like terms. So the new function is denoted as f plus g of x is equal to x plus 6. So when you take f of x plus g of x, that equals f plus g of x. So along the same lines, we want to look at this. We want to take it kind of backwards. So if we have f plus g of x, that is the same as saying f of x plus g of x. And then f minus g of x is the same as saying f of x minus g of x. And f times g of x is the same as f of x times g of x. And finally, f over g of x is the same as f of x over g of x. Now, this one has an asterisk beside of it, a little star, because that means that you have to check the domain. And we will learn more about this in our examples, but I want you to make that note right now. So we'll dive right into the examples. The first thing that we want to do is find f plus g of x. So we're going to use f of x and we're going to use g of x. We don't care about h in this one. So f plus g, we have f of x, which is x squared minus 8x plus 4, plus g of x, which is just 4x minus 3. Remember, when it's just addition between them, we can just combine like terms. So we have x squared minus 4x plus 1. That is our new function. It says to indicate any restrictions in the domain. And restrictions in the domain only happen when we have a fraction or a radical. So in a fraction, so let's domain restrictions. In a fraction, the denominator cannot equal 0. And in a radical, actually a square root, which we're not going to deal with much here, the radicand, which is what's under the radical, has to be greater than or equal to 0. Okay, so when we get to an example, that will make more sense, but because this is not a fraction and is not a radical, then our domain is just going to be all real numbers. All right, in number 3, we're going to take h times g of x. So we need h of x, we need g of x, we don't care about f in this one. So h is x plus 2, g is 4x minus 3, and we want to multiply those. So remember that whenever we multiply binomials, we have to use the FOIL method. So we are going to do the first, outside, inside, and last terms. X times 4x is 4x squared. X times negative 3 is negative 3x. 2 times 4x is 8x. And 2 times negative 3 is negative 6. We are going to combine those two middle terms to get 5x. And so our answer is going to be 4x squared plus 5x minus 6. And since we have no fraction and no radical, our domain is just all real numbers. All right, so the last example I'm going to do with these is a division one, and that's specifically to show you how to do restrictions in the domain. So we have h over g of x. So we care about h, we care about g, we don't care about f. So h is x plus 2. G is 4x minus 3. So neither of these are factorable. That's always something you want to check on to make sure that they can't be simplified at all. But neither one is factorable. So that's our answer. That's all you have to do for that one. Except our domain. When we have a fraction, the denominator cannot equal 0. So we have to see what number will make it equal 0. So we're going to add 3 to both sides and then divide by 4 to get x equals 3/4. So in our domain, x cannot equal 3/4. And you can just leave it like that. Whenever you say the domain is x not equal to 3/4, that means it's all other numbers except that one. So that is an acceptable way to write that. So go ahead and do numbers 2, 4, and 6. Just kidding. I forgot that we go to 10 on this one. I have 2 more examples for you. So the first example of the second section, these are, instead of f plus g of x, we have f plus g of negative 2. And this is when it's helpful because it saves you a step. To know that f plus g of negative 2 is equal to f of negative 2 plus g of negative 2. So we're going to find f of negative 2 by just substituting negative 2 in for every x. And we're going to find that f of negative 2 equals negative 2. And then g of negative 2, we're going to plug negative 2 in for every x. And we're going to find that g of negative 2 equals 5. So we have negative 2 and 5, and we want to add those together. Negative 2 plus 5 is equal to 3. And that's your final answer. So now your for real final example is f times g of negative 1. And again, it's helpful to know that this is just equal to f of negative 1 times g of negative 1. So f of negative 1 is equal to 2 times negative 1 squared minus negative 1 minus 12, which when you simplify it equals negative 9. And then g of negative 1 is equal to negative 1 plus 7, which when simplified is positive 6. So we have negative 9 and 6. Negative 9 times 6 is equal to negative 54. And that's your final answer. Thank you all for listening.